Awesome. Great to see you guys again. Let's just get straight to it. So, two major focuses of this week. We're going to carry on doing more work with our matchstick style problems, using these, creating a formula to predict how many certain shapes will be. So we're going to review that because we had some good work done, but some people were making their lives a little bit harder than they need to be. So I'm going to talk through the way I figure out these problems myself again. And then we've got some reviewing on this, on our order of operations stuff. So let's get to the matchstick problems first, and then we'll sort of see where we're going from there. Okay, so these matchstick problems here. Now I found these, well, actually sent them to me, and I thought these are brilliant because they highlight something that a lot of people were missing, which is doing these tables. These tables really help, guys. So this table here, can you see my, like table A, I just realized you can't see my cursor, silly Mr. B. So table A, for example, what you're seeing is you're going 1 has 4, the second shape has 7, it goes up and you can see it. And this particular table, because it's the first one that you're going to do, you can see here, down here, it has a formula for the amount of matchsticks are taken. Now, as you can see, it's going up by 3 each time. But the first one starts on 4. So how I always think of this, guys, is I look at what it's going up by. See, so that's going up in groups of 3, which means it has to be my 3 times tables. It's going up in groups of 3. It goes 4. That's your first one. 3, 10, 13, 16. So I'll just draw that for you just so you can see it. The first one was 4. First one's 4. The second one was 7. Third one is 10. Fourth, 13. If you had 5, you're going to get 16. And so on. So you can see that it's plus 3. Plus 3. Each time it goes 3 up. So, as I was saying just before, how do you go up in 3s? You use your 3 times tables. So I'm going to call that's n, and that's total. So to get the total, we know that we're going to use our 3 times tables. So if we go n times 3 as our first guess and check, well, 2 times 3 is 6. Now, that doesn't get us to 7. But if we go 2 times 3 plus 1, that gets 7. So literally, what I do is I see what this number is. Plus 3. Oh. That doesn't look... Plus 1. I see what it's jumping in. Like this one's jumping in 3s. And then I go the number times by 3. And then I see what the difference is, because this number times by 3 is 6. The difference is 1. And then I try that formula. I go n times 3 plus 1. Well, that definitely works for that one, because that's how we worked it out. Does it work for this time? 3 times 3 plus 1 is 10. 4 times 3 is 12 plus 1. So we've actually worked out that t, the total, equals n times 3 plus 1. And you can do that for all of these problems. Same thing here. This is 6, 10. Oh, I can see that at 14, 18, I can see that it's going up in 4s. So the first thing I would do is it's 4, it's times 4, so it would be n times 4, and then I would go from there. How do I solve this problem? 2 times 4 is 8. I'm not going to carry on because I'd just literally be doing the worksheet for you. So everybody has to do those first ones. For the Albert Feinbergs, you've also got the coloured ones as well. Same system. Write out how much each one has, and figure out the pattern, guys. That's how you do it. That's how you answer these things. Coincidentally, I think 1, 2, 3, 4, 5, 6. Well, I see the same one twice. I got them off different websites. Anyhow, then we're on to our next thing. So the next thing, still under 10 minutes. Real simple. So we're looking again at the order of operations and using it for solving algebra problems where we have a key. We haven't gotten into any other stuff yet, but we will get there eventually. So what I'm going to do is I'm going to do an example. The first thing you need to do when you're doing this is write down your order of operations, just in case you forget it. So I'm going to delete this, and I'm going to write my order of operations, which is bed maths. So bed, brackets, division, multiplication, addition, subtraction. And once again, addition and subtraction are equal value, division and multiply are equal value. Exponents are more powerful than, or higher value, so they get used before division and multiplication. And the one that gets used first and is most important is brackets. So that's what we've really focused on this week with these questions. I've really focused on using brackets. So we're going to have a look at question 1. We'll do 3 questions. We'll do one from there, we'll do a middle one, and then we'll do an ultra hard one from somewhere here. This one. Okay, so question 1. A question like question 1. I'm not actually going to do question 1. It said 10C. Well, let me check that again. 10C, take away 2. Take away 2. 4 minus. I'm going to change it to. This is not the same as what's written down there. Have a look. Here it has minus 1. So the first thing you need to do is your bracket. 4 minus 2 is 2. Now this here, when you have a number right next to the bracket, that is awful drawing, sorry guys. When you have a number right next to the bracket, it means you need to multiply this number by this 2 by this 2. So 2 times 2 equals 4. 10 times C, C is worth 2. So 10 times 2 is your next step. 10 times 2 is 20. 20 take away 4 equals 16. So the key learning is do your brackets first. Then if there's a number directly next to it, that's a multiplication. So then you would multiply it before you subtract it from the initial number. So you wouldn't subtract 2 from 20, which is 10C. You would multiply this by the 2 by 2, which is 4, and then subtract it from the 20, or the 10C, whatever. Okay, so I'm just keeping the letters the same for the last 3 weeks, just so that you don't get lost with that. But the letters could represent any number, literally any number. And I might have to actually vary that up a little bit, just so that you don't get stuck in the same patterns. So something from about the middle here. This is a good one, because, so 9 plus 4, b plus 2, brackets b plus 2. So I'm going to write something similar. 8 plus 6. Now, once again, if you look at this, we've got to do what's in the brackets first. Now, b's worth 5, so 5 and 2 is 7. And then we've got this one right next to a bracket. So, as I just said before, if it's next to a bracket, it means multiply. So, in order of operations, multiply is before addition. So, we do that. 6 times 7 is 42, you all yell. And then I add the 8, which gives me 50. It's really important that you do that the right order, because otherwise, if I went 8 plus 6, that's 14. And then if I had to do 14 times 7, well, that gives me a total different number. Because that's 14 times 7 is double 7 times 7. So you're getting 98. Which is a totally wrong answer. Now, if you are part of the Chocolate Mice, you can stop watching now. This part is only for the Albert Feinbergs. It is a harder question. A real tricky question. The double brackets here. So, let's do it. The question is 22 plus 4 times 22 minus 15. 4 times. It's tricky to write with this thing. If I was casting from an iPad, I think it would be a little bit easier. I should actually try that, casting from my iPad. 22 minus, I'm going to go minus 16 just to mean that you can't copy me. And then the trick is this has got 2 brackets. And we're going A, B, I'm going to go A, B, C minus B. That's not quite what that question is, but it's very similar to it. You understand that it's almost negligible difference. They're different numbers, but so the first thing you need to do is do what's in the bracket. So 22 minus 16. 6. And then put it back in a bracket, because it's important. ABC, A times B is 15 times C, 30 minus 5 is 25. I've said that all too quickly, but what I've literally done is I've gone 3 times 5, which equaled 15, guys. And then I'm timesing that by 2. 15 times 2 is 30, and then I'm subtracting 5. So I'm still following, because it's in the brackets, I'm just following order of operations inside the brackets. So I'm doing multiplication, 1, 2, 3, and then I'm taking the 5 off. Now I've got this to look at. Now I just go left to right, because these are completed numbers. So I would go 4 times 6. 4 times 6 is 24. Oh, I am mean. And then 24 times 25. Now the reason why that is because the number is right next to the bracket. And if there's nothing written in between, you're multiplying by multiplying. 24 times 25. 10 times 25 is 250. 20 times 25. 20 times 25, it's going to be 500. 4 times 25, so the answer is 600. I just broke that into groups of 10, guys, into groups of 10 25s. And 10 25s is 250, 20 is going to be 500, and 4 25s, if you don't know, is 100. So the answer would be 600. There we go. That's a breakdown of everything you have to do this week.